Hi everyone, welcome to another Common Lisp study group. I'm your host Ron Baden with the Land of Functional Programming. Today we're going to be discussing a library, another generator library. We've been looking at and exploring different generator libraries that are available in Common Lisp for the last month and a half, although last week we did a special edition with looking into the Screamer library for non-deterministic programming and doing a little bit more of a deep dive into its compiler. Today, this library that we're going to be covering is called gtwiwtg. It is an acronym that stands for Generators the Way I Want Them Generated. I posted the link in the description of this video for folks who are wanting to take a look at the GitHub repository while we're covering it today. I'm going to be covering mainly some of the examples that are in the tutorial, mainly because I'm still playing around with this library. There's a couple of specific things related to a couple of examples that I would like to do, mainly in a reactive sense and reactive programming sense, that I wanted to see if this library would cover. I'd like to thank one of our regulars who introduced me to this library, because I didn't realize that this was another library that existed, so thank you. This is a library that is available on QuickLisp, and we're going to be going through a basic example of setting up a project, as you can see, because I just have my standard REPL open and haven't actually started creating a new project yet. Before we begin, a couple of announcements. Number one, on November 11th, Judd Taylor, one of our founders of the Common Lisp Study Group, will be doing a presentation on the High programming language, which is a Lisp dialect that runs on the Python virtual machine. It actually is a transpiler that transpiles to, my understanding is, Python AST code that will allow seamless integration with Python code. So you can actually call Python code from Lisp and from High and vice versa. So folks who are available on November 11th, please stay tuned and join us if you can. The timing is available on the meetup page, but briefly it is 7 p.m. Eastern Time. So that might be pretty late for some folks that are watching our videos and joining us live stream internationally, but take a look at your time zones and plan accordingly. If you can join us, that would be great. Additionally, yeah, go ahead.
Are you streaming on YouTube?
Yes, seeing it. Yes, I am. But let me see. For some reason, the permissions were set to the wrong thing. Okay. So it was a private video for some reason instead of a public video for permissions. That's fine. So just briefly for folks who apologize due to some settings, I will go ahead and do this cleanup. But welcome to another Common Lisp study group. I'm Ron Baden with Land of Functional Programming. Today we're going to be covering a library called a generator library. You may have actually noticed we've been covering generator libraries the last few weeks. Today this library is called gtwiwtg, which is an acronym for Generators the Way I Want Them Generated. This library, the GitHub repo URL should be available in the links below. Please, in the YouTube description. If you have questions regarding it, please, it's available so that you can take a look at the documentation. Before we begin, just one quick announcement. On November 11th, Judd Taylor, our regular, one of our regulars in the Common Lisp study group, and one of the organizers of the Atlanta Functional Programming Meetup, will be doing a presentation on the programming language Hi, which is a programming language that compiles to Python, AST, which allows seamless integration with Python libraries. So that means you can call Python from Hi and vice versa. The timing is at 7 p.m. Eastern Time. Please check accordingly with your appropriate time zone, and when you get a chance, if you can, please join us. So to begin with, let me go ahead and create a new project here. So gtwiwtg, which is somewhat of a mouthful for me, but it's a nice little acronym for what it's about, is available on Quick Lisp. So we can actually go ahead and create a new project for this. And you can actually find it, it's just simply just a simple depends on gtwiwtg. I think you're gonna WTG. And let's quick load this guy. Once we're done here, as usual, I will post our workshop code on, did I spell it wrong? Oh, right, never mind, I spelled it wrong. Interesting. For some reason, let me see, maybe I misunderstood this. Oh, okay, my mistake. Let me start over here. gtwiwtg is not available in Quick Lisp, it seems. You have to actually clone it. I forgot about this. I actually cleaned up my repositories when I did this. Let me just quickly go ahead and clone it. It's a pretty quick clone. You can get it from GitHub. Actually, you know what? It might be better to put it in our local projects, but I'll do that afterwards. Okay, so move this over to Roswell local projects. Okay. Good. 1 second. Maybe it didn't recognize the fact that I just moved it. There we go. All right. So in order to use this library, you're going to have to clone it into your local project, and then you could just set up your quick load project to actually go and do this. I'll go ahead and put in the instructions in the README that that's what you do, just as a reminder. This library is actually pretty neat. Let me just go ahead and first load up our main.lisp that got generated. So, for example, so the way generators work, for folks who aren't familiar with the concept, it's kind of like a lazy evaluated infinite sequence. Series did something similar in that sense, because you could specify in your pipeline the initial conditions and the step functions, if you recall our discussion on series, where it takes that initial value in that step function, and until it hits some sort of predicate, it will keep on generating the next value in the sequence. The way internally, and I still haven't kind of dug into this, but my suspicion is gtwiwtg does something similar. An example that I'm going to be showing you is an example that is in the something is a pretty simple example. The example that's in the tutorial, it uses it's computing prime numbers, so it created, like, a function that you would do before. I'm gonna go and just create evens, just because it's kind of like something similar, just so that I don't have to go and write essentially the naive test for primes, although it's in the documentation. I'll let you guys take a look at that. A simpler example of this is, if you're using something in normal common Lisp, you might start trying to compute all of the even numbers from 1 to a certain number. So if we started, say, from 0 to n, and then we basically check when even p I, we'll go ahead and collect I. Okay, so we compile this guy, and we can see that if we do even p, say 100, it will, oops, did I spell that wrong? Oh, that's right. How do we do? Sync. Now, let's do that again. You can see here where this is a very simple example of using loop. This is nothing new for folks who have been following this, but if we wanted to keep creating, let's say, all the even numbers, okay, which is an infinite sequence, we could define, in using the gtwiwtg library, a simple generator that simply calls filter, where you could pass in a predicate, and you can call a basic generator called the range. And this is kind of like scan range in series, where you specify from, and if you don't specify an upper bound using 2, it will just go ahead and, it will just keep generating until the application, like, either crashes, or you abruptly kill the process. Now, folks looking at this signature might notice that you don't even actually necessarily need to do this for this particular example, because we do have a step a step function here, which is the by keyword. So you can actually say start from 0. Actually, let's say start from 0, and then increment by 2, and you automatically get all the even numbers. I'm not going to use that for right now, but it is available for folks who are doing some of this more basic kind of experimentation. So when we define this generator here, we can use it, but if we use it as is, it's just going to keep generating new numbers. So obviously we want to restrict that. In this library, the gtwiwtg library, you have a take function actually that will allow you to specify how many values that you want to actually get from a particular generator. So we can call, so let me just do this and then that screen. Let's see if that's large enough here. I'm just looking at the video stream here just to make sure everything looks fine. All right, so I'm going to go ahead and actually run this in my REPL. If we run, say, for example, tg take, let's say, the first 10, or in this case, we can actually get the first 100 because we actually did that before, and we call all evens, you will see that, oh, my apologies, this is the first 100 evens in this little sequence. Take 25. So, point is, you can see that this this generator, this simple generator, doesn't actually generate the next value or keep generating the next value until when you hit when you use the take function. Instead, what it will do is it will keep a counter of how many values you are getting, and it requests behind the scenes what the next value is. Let's go and break this down a little bit, because this was particularly interesting to me because in the series library you had to specify a sync specifically here. Take is very, very familiar to those of you who come from libraries like, say, Haskell and even Clojure, because they have something, actually, I think semantically it would be identical to the take function that's here. So let's, kind of break this guy down here for just a minute. Take, let's say, 10 all evens. What happens behind the scenes here? We'll do a macro expand. Is that a macro form? Interesting. I thought that this was a macro form for some reason. Maybe this is. So these are all actually functions. When I originally looked at this, I was under the impression these are actually all macros. So this is something new. My suspicion of this was a little different than what it is actually doing. So I thought these were macros that are actually generating some stuff behind the scenes, something similar to the way the series library goes, but it actually looks like I was wrong on that suspicion. One of the reasons why we do, kind of code spelunking here on the study group. So that was a basic example, right? Let's look at something even more interesting, which is, let's say that we want to write, say, a grep file, Okay, we're going to write our own grepper. All right, and it's going to be a dumb grepper. It'll take some sort of search pattern, you know, uh, and a file name. This is an example from a tutorial that I thought was pretty neat when it actually wrote this. So this is going to be straight out from the tutorial, which is we're going to write a pattern. We're going to take in a file name. What we're going to do is we're going to go ahead and filter based on the lambda function that we create that takes the line. So that's the index of the line number that we're looking at, as well as and what we'll do is we will actually search on this line, and we will actually go in and search actually. Right. So we take the pattern, which is our subsequence one. For folks who haven't seen search, it'll do kind of like an interesting. I think it's a. I don't believe it's a logarithm, a binary search. It's a linear search in the sequence that we're looking at, and we'll just grab the interesting. 1 second. I think I may have messed up one of my parentheses. Okay. For some reason that's not working the way I was expecting it to. And what this filter does is every time it actually retrieves a match, what we're going to do is we're going to zip. And this is one thing that I kind of like about this library. It actually has a zip function, which is something that I kind of got accustomed to in Python. What it will do is it'll take the range that we were for some reason gtwiwtg range, and we'll get the file. Let me see if this will work the way I expect it to, but so gtwiwtg has a generator that will grab each of the lines of in a particular file for you, and it'll zip them up for you based on the pass. So to review this piece of code is we're basically creating a generator for the pairs of line numbers and the lines associated with the line number, and we're matching against that a particular pattern to see if that given line matches the pattern that we're looking for. To give a very brief example, we're going to use let's say in the examples.lisp that's actually available in the library. That's located for folks who are interested. It's in I remember, yeah, it's in the top level. It's only like it's a very small library. The library is only like a few files. So what we'll do is we will actually grab this guy. Let's see if this works. All right. Let's go in and do this. Now, in order to iterate through this generator, you can't just normally use the loop macro. Like you have to, there's some accessors that you have to go through to actually use it. But this library actually provides a for function that we could just go ahead and use. You may have noticed that there's a couple of other things that this library uses, but we're going to use this for the sake of example. And of course, this allows us to specify different counter variables expressions. And what we'll do is just make sure that this is compiled. We're just going to go and look for all the functions available in this library. So examples.lisp. And what we'll do is we'll go ahead and use the format function to actually go and grab the line number as well as the line that actually specifies the declaration. So if we run this, I guess I can only run this here. We'll see true, but it's not actually formatting, not actually running the actual code all the way through. Give me a second here. Did I give the wrong path? Let me see if I could provide a path here. Interesting. There should actually be several examples in here, but for some reason it is not showing up. Let me do something. Let me go and look at this guy as is. File lines, and then we specify the file name. Let's see what happens. We've got a generator. Let's do this. Let's call take to get the first 10 lines of this guy. So you are getting all that. So there might be a piece of code that's messed up in my generator. So let's go through this line by line because there seems to be just a couple things that I might be misunderstanding here. So first, what we did was we grabbed the actual file, and we used file lines to create a back generator. As you can see, if we use the take function, it actually does what it's expecting to do, which is opening up the file, and only when you ask for the next line will it actually read the next line from the file and return it. This is a simple way of actually, dealing with reading files line by line in a lazy fashion. The next thing, obviously, that we're doing here, which I think is probably what's causing the problem, but we'll see, is we're actually attaching a line number to them. So the way we could do that is we use essentially the zip function from the library to actually grab well, to actually pair up the line number with the actual line that we're actually reading in from the generator, from the the file lines generator. But this in turn is its own generator, by the way. So by doing this, you notice that the return type of a zip is what's called a thunk-back generator. Thunk-back generator are basically, think of thunks like essentially pieces of closures that actually get evaluated upon on demand. At least that's kind of how I think them. There's context associated with the actual what's it? The evaluation of actually executing that piece of generator to get the next value. I haven't actually dug deep into the thunk-back generator and the stream-back generator, but they're very similar in how they both are implemented because they're implementing some of the same functions in the same interface. So this looks like it's actually doing what we expect. And again, we could see that by just simply by just doing another gtw take, and let's get the first generated of these. You can see we've actually associated this in a zero indexed way, a line number associated with each string. So the next thing is that this function was doing is the filter, which means it looks like the filter should be working as I expect it to do, but let's see what's going on there. I see what the problem is. I forgot I made a mistake here. This is a pair. Since these are associated pairs, I made a mistake on that to actually go in and make a pair. So this should actually do what we expect it to do now. Why? Yeah, that's what I thought it would do. Okay, so let me try and scroll this up, pull this up a little bit, and let me see if this actually runs as is too well. There we go. So what this code is doing is it's actually going through each line in the file. It is grabbing all the function signatures that are associated with the file and then spitting them out. This obviously is what you kind of do when you're using grep and other things. You could be more sophisticated, maybe use ppcre if you really wanted to, and other things. The point is very similar to what Series does behind the scenes, and what a lot of generator libraries do behind the scenes is it waits until it asks for the next item before this library actually goes and generates that next item. That's kind of what a generator is, like I mentioned before. There are three types of functions that gtwiwtg actually provides. But before I begin there, let me see if there are any questions. Okay. All right. And let me go and check here. No. Okay. Okay. Looks like there are no questions. Okay, so let's talk about what does gtwiwtg provide in terms of functions to create various types of generators. This piece of code that we're looking at, the grepper, is kind of illustrating the three kinds of functions. Well, two of the three kinds of functions that we're associating with creating to creating generators that are available in the core library. So just like in other libraries, there are things that construct, things that combine, and things that consume the core data structure. gtwiwtg is no different. It has functions, and they are Lisp functions, as I have now kind of proven. That construct generators. There are Lisp functions that combine generators and create a new function. And there are Lisp functions, and in the consumption phase, there might be a few macros that you might end up, hitting that create and consume those generators. Okay. We saw already that the most basic of the generators, the so-called generators that are probably going to be used a lot, and those are things that are dealing with like sequences and creating ranges. Ranges, as you've seen, has already been something that is particularly useful. You can generate using the step function the initial value from, you could say 10,000. You could actually specify maybe the increment, and you may notice that there is an inclusive and an inclusive flag. If inclusive is set to true, what it will do is, and let me actually make this a little bit smaller. Let's say 100. Okay. What it will do is if you end up calling take on this, which is again a function that actually consumes the generator, and you ask for 100. This is going to just run until it hits the end. And you may notice here that inclusive actually includes 100. If you end up using, say, nil here, and let's say that you end up asking for 10, it grabs everything up until the upper bound, which is, it's not including 3, 6, 9, 10. It gets 10 integers, but doesn't actually include the last number that you're asking for. Let me just make sure that my understanding is correct on this. Oh, there's still 10 here. Let's say that we do 100. Oh, right. Sorry. Wrong thing. Let me do something else here. Let me go ahead and def parameter generator. Now, we can just call let's do this. Yeah, that's right. So you can see here that the difference between the true or false, it's inclusivity or exclusivity on the upper bound. So if you end up wanting what's called a half open range, and you want the upper bound not included in your set, you need to set inclusive to nil in order for you to actually question, can we inspect the range back generator? Yeah, we could do that. First do this, then let me see if I can just do that. grab range back generator here. So if we inspect the range back generator, it the slots are telling you whether or not it's dirty. Is basically has it been used or not. Whether the generator is no longer generating is and you can actually see it, and this is useful for finite generators. You can actually see if the generator needs to be reset, for example. Which brings up another thing that we should actually try. In some generators languages, generators are not immutable. At least if you look at it from the Python generators, they are. If you consume from the generator, it's basically like a hot stream. So whenever you ask for more stuff, it doesn't go start and replaying from the beginning of the generators. It always starts from the last point, the last value that was consumed. Well, the next to last before the last value that was consumed. To give an example of this, let's go ahead and grab our first 10 generated 10. Let's grab 10 values from the generator, and let's grab another 10 here, and you can see that it complains. Why is it complaining? It's failed with. Let's go look at what the generator tells us. It's dirty and it stopped. Interesting. It stopped generating as soon as the take was done. So you can't actually consume from a generator twice. That's pretty weird. Maybe I used this incorrectly. Give me a second. Range. So I'm going to have to look into this. This is kind of interesting. For some reason, I was under the impression that unless a generator is complete, consumption actually can be used multiple times. But it looks like that is not the case. Okay, this is a note that I'm gonna go and investigate just because I'd like to show you the rest of this library rather than making this somewhat of a interesting debugging session. But this should be expected for folks. The flags being set the way it is. The stopped flag, I'm a little surprised just because not everything in the generator was consumed. So I would have thought that it would actually wait until the upper bound is called before it actually sets the stop flag, but I guess not. It might be used to stop the actual generation, and then later on you can't actually go in and start it up again. That's still an unknown question. Like I said, when I was playing around with this, I was playing around with examples that were pretty straightforward. One thing that I'm going to mention before we move on to the next constructor that's available for generating stuff is if we just call gtwiwtg range, okay, without a consumption function, you may have noticed that we constructed a new object for the range back generator, but we did not actually go and start evaluating it. This is very typical of most generator libraries because for folks who are familiar with generators that implement they implement the iterable protocol essentially, and that's usually protocols that give you methods for grabbing the next item inside the generator whenever and only when you ask for it will it actually go and grab the next item and then continue to consume. But otherwise, it will not do any computation. It's just essentially an object that's in memory. The other aspect of this is different generation functions create different types of generators. As we saw so far the range-back generator, the thunk-based generator, as well as the stream-based generator. And those are very familiar with the types of data structures that internally the generator is actually returning. So if we're actually taking, for example, say, generators for dealing with strings, we're going to get something different. To deal with basic sequences, you don't necessarily have to use range and then go back and do some sort of lookup on top of your sequence that you're dealing with. You could just use simply this function seek to actually go and create this. Seek will take in any sequence and then a starting value and then create a generator to retrieve values from that particular sequence. So here, and this is an example that is in the book, in the documentation. It actually goes and retrieves a sequence back generator for actually retrieving stuff within a sequence. That's a good point. So Richie, one of our regulars, makes a good point that when we were talking about take earlier, it might very well be the semantics of the take function itself as to how it expects a generator to be. But I'm not quite sure, just because since there are two flags there, dirty is what I would think that would be determining whether or not we would be starting from the beginning of a generation sequence or the end. I mean, or not. But dirty doesn't necessarily mean that it has been terminated, right? Stopped, though, being set to true means if you're trying to re-grab stuff from this generator and it's stopped, it should throw an exception. I would expect, just because that means that there may not be any more values to generate based on the specification that was passed into the original generator constructor itself. Again, this is something that I need to play around with and see what would be most appropriate. But to get back to sequence-back generators, sequences and sequence-back generators can handle basically any sequence. As you saw with this example, we're dealing with the string. We can also pass in, say instead of a string, we can also, pass in a basic list. Say this, and we pass in, AGLO, and it will generate, a different type of generator. And the sequences generator what it will do is it will figure out, based on the data structure that you are attempting to construct, and create a generator of that type. So if we made instead of making this into a list, if we ended up making this into a vector of atoms, coded values. Oops, wrong way of thinking. Coded values. Okay. Now, when we go in and retrieve this, you'll see that it will generate the appropriate generator, whether it's a list back or sequence back. List back generators, because of the way lists have to be retrieved to get the next value, have a different set of semantics than generic sequences, which usually tends to be assumed as being contiguous. So this is why there's two different types of generators based on that. Again, the main thing that you should realize is that each of these generators are not actually generating in the background. They are not, they didn't generate any additional items other than the object that you see right there. Now, there are other generator types constructors. What we saw before, this gtwiwtg range from, say, 2, all right? Or let's say 2, let's say 10, okay? Which range will generate all this. There's shorthand for this. You can actually go in and say, you know what, I want you to generate only, say, the first 10 integers, okay? And we'll get, these two are roughly equivalent. So if we ran this, we should get identical results. So if we did take 10 range, we got that. If we did the same thing here, take, and you see that they are identical. There's another one that is an infinite loop, but it repeats its arguments in the order that that they appear in. So it's kind of like a cyclic generator. There's something called noise, which you can use to actually create random numbers. There is sequences to grab from a thunk. So from thunk until, from thunk times, and so forth. There's also things related to generating sequences based on a recurrence relation inside this library, which is pretty neat. Of course, for folks like me who do quite a bit of network programming, one thing that I find very useful is things that deal with streams. And in this library, there is a very nice from input stream generator that can take in a stream and a reader to actually read each value from a particular stream, and it'll actually generate a generator that would grab the next value in the stream to actually do some processing. So those are, I'll let you get stop on the construction here for a minute so we can keep moving on. There are plenty of these, like, basic things. We talked about files and streams and all these things. Go and look at I'd say, the documentation to see what, for particular uses, that you might need to you create your own generator constructors. But look and see if the standard library functions might help you in order to help create some of those, because it might be that there's already one in the API that will suit your needs, instead of you going back to, kind of the lower level functions, whether it be sequence back generators using sequence or range-based generators using range. Like series, there are functions in the gtwiwtg library that allow you to transform and combine different generators to create more complicated generators. So one of the most typical things that are always included in some of these libraries is something that will allow you to map a function to a current generator to create a new generator that essentially applies that function to each value that's being generated by the lower level generator. So, let's take an example of this kind of like map function. So we created a basic thing like with times. Let's go ahead and just do, let's create a new generator that again, we're going to use take because we need to, although we haven't talked about consumers yet, take is kind of your most basic consumer that will take in a generator and then consume it. And let's take the first 100 values of mapping the lambda function that just squares, and we'll take that and generate it using gtwiwtg gtwiwtg times 1000. So we're just creating a range-based generator, grabbing the squares of it and taking the first 100 of them. So you can see what this is doing here is it created, and I should have really did this. Let me first grab the type here. This generator that we just consumed earlier is essentially a thunk-backed generator because thunks, like I said, are kind of like closures. They're keeping track of the current value, the state of the generator, as well as whatever they previously computed. And in this particular case, it's also keeping track of the function that needs to be applied to the next value. So if we go and look at the thunk-back generator, you could see the next function and next predicate function are available. There's also a function here that also talks about stopping the sequence that's applied as well. If we, for example, consume this guy, and let's say I consume take 10 start. Now go back to this. Interesting. So this is something that was brought up to my attention. Richie just mentioned that in the code there is an explicit comment that says consumers explicitly stop the generators that they're consuming. So this confirms what I was suspecting earlier, but I wasn't sure. I didn't think that's what it was doing, or that's what it would do. But it looks like if you're using gtwiwtg to create your generators, and you're using their generator consumers, the internal semantics of the data structure, the generator data structure that's provided by the library, assumes that the consumer of the given generator is going to kill it when it is complete with what it's attempting to do. And what that means is even if a generator hasn't completed the generation of what it was supposed to be generating, and what I mean by that is it didn't hit the upper bound of whatever sequence that it was doing, and this is specifically in the case of finite generators that you're leveraging, or even in some cases if you want to create an infinite generator and then just call the next function all the time on it. It looks like you cannot actually use the same generator twice in two different expressions. Instead, what you would have to do is reconstruct it, which means you would have to replay the generator each time. That's a bit annoying. I'm a little disappointed that that's the case, but kind of figured that might be something like that if I looked at the code. So thank you for looking into the code for that, just to give me a heads up on it. Save me some time to actually do some code spelunking. So to get back to what we were talking about in terms of transformation functions, we saw a map. We've already used filter. I already give the example that's in the tutorial is using filter quite a bit. Basically takes a generator and a predicate and creates a new generator. And that also, as you saw before, creates a thunk-back generator as well. Inflate also generates, if I'm not mistaken, a thunk-back generator, but I'm not entirely sure how to give an example of inflate. So the documentation says what inflate does is it takes a function fn. So let me just show you the function signature here. Shift A. it takes a function fn that is acting like a factory method. So what it does is it will generate generators using the values produced by the second argument, the generator that was taken in. So what inflate is essentially doing is it's a generator factory for transforming values from that are acting as seeds from a different generator. Um, so you can think of it, for folks coming from the Haskell world, kind of like a bind operator essentially. Um, it's grabbing the next value that's coming in from the generator that it took in as a second argument. And it says, okay, from this value, I'm going to create a new generator of this particular type. So one example that is in the tutorial, the documentation that I think might be useful is taking, the generator function times and creating a generator that will just create sequences up to a particular upper bound that we specified. All right, so we can take a look at this pretty simply by just running for x and that is associated with this inflation of time. So we're going to create the time generator from a range. Let's say that we're just going to do this up to 5, just so that it doesn't run 0 to 5 inclusive. And what we'll do is when it's 0, we will just hit, we'll terminate the line. Otherwise, we will print it. Then we'll add the space. Let's see what happens there. Oops. Right. I forgot. This is an exported symbol. Okay. So what this is doing is the range back generator is creating, our standard sequence. We were talking about it before, from 0 to 5. And what inflate is doing is it is asking for each value of that range back generator, and it's generating a new generator that essentially is times that. And if you remember what times is itself a generation function that generates sequences up to a particular upper bound. It is the equivalent to just calling range to some upper bound. That is what the inflation guy is doing. It basically returns each new one of these, and then what we're doing is we're executing that generation by calling it every time, and that's essentially the same as it calling next whatever, and it will go and run that multiple times. So, and prink here is what's actually acting as a consumer of this function. Now, there is a ton of transformations that are in this library. Zip we've already looked at, which is really useful for actually generating multiple lists. It is the shorthand to actually creating a list, mapping the list function on top of two different generators. Another one is indexed. So the code that we wrote earlier. Just go this way. The code that we wrote earlier here, where we're actually zipping range gen, we can actually simply replace this guy with indexed, and it's the same thing. So this is equivalent to essentially gtwiwtg colon zip, and we call range, and you pass in the generator that you're using. So here we're calling file lines, which I think is makes things a little bit more convenient, so you don't actually have to write all that extra code. So the two lines that we have here, line 19, line 20, are basically equivalent. There is a skip function. There's a concatenate generator transformer, skip transformer, skip while, merge, truncate, inject. There's it's particularly useful for you to go through this documentation to actually go in and figure out what each of these functions is. The one thing that I'm going to bring up is for folks coming in from the scheme world, and this is particularly a good warning. That bang that you're seeing there, it's not telling you that this is an immutable, modification, or it's because if I remember correctly, set bang actually returns. It guarantees you to return a new instance of whatever the modification that you're creating that's bound to that variable. In this case, though, incrementally building generators, and this is why the bang is written that way. Incrementally building generators is a little bit of a cautious art, and when you're doing it, it goes back to what we were talking about before when we were talking about the termination semantics of a generator. Basically, generators can't be combined twice. The same generator cannot be a part of two different other transformed generators. And what that means is if you're using intermediate generators in, say, like a let binding, you might think that you could pass those same variables to other combination functions more than once. You'll end up getting the kind of error that we saw earlier, where it's recognizing that the general generator that you created has already been used, and you might get some undefined behavior there. And undefined really is that the library was not designed so that way, and there's a basic design principle the library was specifically created for, and going outside of that might end up, you might think that it's working the way you expect it to, but at some point the designer might go and correct that because it wasn't actually a bug. So let's take a look at this. Let's say that you were trying to create a new generator. Actually, I'll do this here. Sample of error call occurring when combining same generator types. We're going to just basically create, this as a simple example here. Say that X is us generating the first 5 integers. All right. If we go and try and zip these guys to create all the pairs between the between 1 and 5, you're going to end up getting something like this, which is an error that basically says you're combining the same rangeback generator twice. It recognizes that, and that's not because that's not expected behavior. They don't expect you to do that. There is a general rule that the library uses, and that's where the bang comes from. That's where the exclamation point comes from. And that is, if you pass a generator to more than one combining function, or if you in a combining function are all those functions that are associated with the exclamation point, an error will be raised if you pass the same generator to those combining functions, just because it recognizes that the same generator is being used multiple times. And even the author mentions this, that although he was careful to try to make the library consistent, there might be some places where you will where if it's not keeping track of what generators have been combined with others, you might get some surprising behavior. But in general, the library does keep track of whether or not generators have been combined. So that's something to be aware of. So we talked about, and this is probably going to be the final topic here, but we talked about already consumers a little bit, especially because we've been using take now. But in general, if you are working within the world of gtwiwtg, one of the consumers that's available at you that is not take is the for consumer, and this is considered to be so fundamental that the documentation calls it the fundamental consumer, and we've already seen examples of this. You could see here when we were using the for loop that we're within the guise of this. Within the scope of this for loop, we don't actually have to reference anything here, and we didn't actually do this in a functional manner. If you actually expand this, for is actually a macro that loops until it finds or it hits some sort of terminating condition, and that terminating condition is remember, generators are objects, and part of the protocol in the generator protocol is that it has to have a next item and it can call next on it. Okay, so those are the two main things of all basic generators. Well, of all generators in the gtwiwtg library. So what this does is you can see it creates the generator through the grepper. Remember, the grepper is what we defined as being the generator. It's a thunk-based generator. And it uses unwind protect to actually loop through it and grab the next value. And you can see that on line 30 here. And this is particularly useful here. gtwiwtg has a next here, and it grabs the next value and then formats it. Now, one thing that I'm going to mention here, and this is why I'm a little surprised, is I had assumed that this stop here that it's doing, that this actually wasn't necessarily needed until it knows that it hit some sort of terminating condition. But it looks like it is assuming that it's your consumer, as you can see here with for, is going to be the one that's ultimately responsible for explicitly calling stop on the generator. And it assumes that for all basic things. So it's going more the route of a pure functional based generation approach, in that you need to reconstruct the same generator and call it multiple times in order to grab something, and no generator can ultimately be alive for a long time. Um, I don't know how then you can implement some semantics related to, like, say, if you want to use like this to wrap it a network call. Just because if you have to stop the generator, you're closing the network call, which means every time you want to read from the network, you're going to have to go and reconstruct a new generator object for that. So you're keeping track of the file handle for that generator every time. There's some design things that need to go into this. I was looking at this library just mainly to see how I can continue reading from a socket in a generator fashion. But this macro is used in a lot of places. This for macro that's provided by the library. It's actually the basis of what we were using for take, and the basis of what we were using for other consumer convenient generator consumers that are part of the library. There are three parts to this that I'm going to just briefly mention. The binding form, as you can see here, that's the what ultimately are you deconstructing, and you saw that here because we're using destructuring bind here. And the generator itself, and then whatever the body is. And the body could be one or more forms that's leveraging those values. And so interestingly enough, I like this library, but series is faster in terms of performance. So the question, how do I like this library compared to series? Compared to this has a lot of niceties in terms of more modern understandings on how you should generate new values, and it didn't take the meta compiler approach that series used to actually create the generation functions. That said, because series is kind of restricting you to do certain things in terms of uh, in order to create really highly efficient code, and this is things like making it easy so that it can infer types of the underlying data that it's actually combining and all that. It actually does it does create some fairly efficient code. Now that said, this library itself is uh, it has some really nice features for inflating and for zipping, things that I'm kind of used to from other programming languages that, because series hasn't been updated in a while, does not have. So I would use uh, this library in cases where I need those pieces of functions, those use cases. Um, but for a lot of like algorithmic things where I can leverage series, I would probably use series just because it does generate better, more faster native code, and I think that's a testament to its design and the fact that it's been able to do something that's similar, and it's been around for 20, 30 years, and nobody has really modified it. Really shows that clearly that design has stood well. Other questions? So I'm gonna stop here because there are a few other features that I want to talk about, but I would like to in this library, but and we'll touch base on it next week. Um, but those look like things that would require a little bit more in-depth discussion, particularly the anaphoric macros that are part of the library, as well as how would we use this for accumulators. Um, but I won't rush it. I will. I will continue this library evaluation next week. And just a reminder, AFP will still have the high meetup on November 11th. So until next time, if there aren't any other questions, I'm going to call it. Question: will high be recorded? Yes. Our high meetup is virtual. It is going to be online. Um, I will be. We will be recording it. It will be available on YouTube. It will hopefully have folks who are there be engaged in the discussion either on YouTube Live or if you're in our meetup, we could do it. So, but that is going to be recorded. Other questions? All right. Thank you for joining. I'll see you guys next week.
Are you all fair?
1 second.